Hello, this is the first chapter in physics space topic for GCSE, and I'll be discussing the life cycle of a star from birth to death. Every star starts off from a cloud of dust and gas called a nebula, as you can see in this image. Over time, gravity pulls all this dust and gas into one point to form a protostar, which is the beginning of a star. But why are some stars bigger than others? This is because inside a nebula, what is actually happening is that the denser part of the nebula, the core, collapses in fragments into lots of little stars, and naturally some stars are going to be bigger than others. These fragments have to be at least 10 to the power of 28 kilograms, so that's 20 times the size of Jupiter. And if it is big enough, then it can ignite and be classified as a protostar. But if it is too small, it will turn into a brown dwarf, called a planet. Now, ignition only happens when so much dust and gas has been drawn inside the early star that its core gets really dense, and the gas and dust surrounding it start to collide. All these collisions release thermal energy, and once there is enough, nuclear fusion can occur. Hydrogen nuclei, which is a single proton, and makes up most of the star, can then fuse together to form helium nuclei, and this gives out huge amounts of energy which keep the core of the star hot. Its mass is now fixed once fusion has started, because it produces stellar winds stopping the infall of dust and gas, and is now officially called a young star. This young star, though, will only have 1% of its final mass. Our new star now undergoes a long and stable period in which the outward pressure, or in other words the explosions generated by the constant fusions, is balanced by gravity. This is why the star doesn't just explode. Our Sun is in the middle of this stage actually, but don't worry because this typically lasts several billions of years. But when it does eventually happen, it will become a red giant. When the hydrogen begins to run out, a star will begin to collapse as there is not much energy pushing against gravity. But it only collapses enough for helium atoms to combine into carbon atoms, and this pushes the outermost layers out, making the star swell up and becoming a red giant or a red supergiant depending on the size of the star. If it's a really big star, then it'll be a red supergiant, else it'll become a red giant. Iron and heavy elements are also created in the core of a red giant, or a red supergiant, and the giant goes red because its surface starts to cool. When our Sun runs out of all its hydrogen, it will, because it's quite a small star, it becomes unstable and its outer layer of dust and gas is ejected out, leaving behind only its core and creating what we call a white dwarf. As the white dwarf cools down, so little energy is released that it becomes a black dwarf and is pronounced dead. But good news if your star is big enough to become a red supergiant, but good news if your star was big enough to become a red supergiant, then it can die in a huge explosion called a supernova instead of dying in old age. So what happens is it gradually creates heavier metals than iron, and will start to build up in the core, and the star will become layered with the lightest elements on the outside. Once the star passes the Chandrasekhar limit, it will start to collapse and implode until suddenly the star explodes, just like you see the Death Star explode. And all the metals it has created will be expelled into the atmosphere to create new planets. After the huge explosion, only the core is left and it becomes a neutron star. But alternatively, if it's dense enough, it could become a black hole, where even light cannot escape because the gravity is so strong. So, that should cover the life cycle of a star. I hope you found it interesting and worthwhile, and I thank you for watching.